In question D, they ask, using your answer to C and the data in B, estimate the magnitude of the resistive forces acting on the bus. So the magnitude of the resistive forces acting on the bus. Okay, so what do we get from C and B? Well, in B we are told that we have an output power output of 70 kilowatts, so 70 kilowatt. And in C we see that the power to increase the potential energy, so I'm going to call this PE, the power for the potential energy is 5.4 times 10 to the 4 watts. Now we can see from here that there is a difference. The difference between these two, if I subtract the difference of those, I get 1.6 kilowatts. 1.6 times 10 to the 4 watts, because this 70,000 obviously is 70,000 watts. So when I subtract those two, I get that. Now this is the power that is used to overcome the frictional force. This is the extra power that the engine has to put in to overcome the frictional force. Now we want to work out the magnitude of the resistive forces. Now what formula do we have that relates that? Well, if I go here, I get that power is equal to FV. So I can put that in here. So from my force is what I'm wanting to work out. The force is going to equal my power, 1.6 times 10 to the 4 divided by my V, which is 6.2, and I get 2.6 times 10 to the 3 newtons. Again, I keep my number of decimal places, my number of significant figures to 2, 1 decimal place, in line with my data that I've been given. Then it says, the engine of the bus suddenly stops working. Determine the magnitude of the net force opposing the motion of the bus at the instant when the engine stops. Well, if I just redraw the diagram here, roughly over here, if I got the bus there, we know that there's a resistive force acting in that direction, and that force we have just worked out to equal 2.6 times 10 to the 3 newtons. But we also have the weight, the component of the weight. Now, the component of the weight that is actually going to be resisting this force is going to be this component over here. I'm going to draw it in red. Will be that one over there. That's that one that will be resisting by similar triangles and so forth. This angle over here is 6. Now, the weight of the actual bus is actually given by, the weight is going to be 8.5 times 10 to the 3, that's what you're told, the mass, times 9.81. That will be the weight. And so this component here, this component that we are looking at, is going to be 8.5 times 10 to the 3 times 9.81, because this is opposite. This is your hypotenuse. This is opposite. It's going to be the sine of 6 degrees. So that's due to the weight of the object, and this is the amount that was being overcome to increase the gravitational potential energy. That the power from the engine was overcoming that amount to give it greater potential energy. But we have to add to that this frictional force over here, 2.6 times 10 to the 3 newtons. And when we add those two together, we get in the region of 11 times 10 to the 3 newtons. Again, keeping two significant figures for the sake of accuracy. And then our final question here, it says, discuss with reference to the air resistance the change in the net force as the bus slows down. So as the bus slows down, air friction is going to decrease. Air friction will decrease as the bus slows down, as the speed decreases, and so therefore the net force will decrease.